In 1960, a man looked at Manhattan and said, "I'm going to put a dome over it, 2 miles wide, from river to river, every building, every street, every person inside a glass bubble. No more snow, no more pollution, heating costs slashed by 80 times." And he said the savings from snow removal alone would pay for the entire dome in 10 years. People called him crazy, but the math worked. His name was Richard Buckminster Fuller. His friends called him Bucky. Time magazine put him on the cover, and he called himself the world's most successful failure. This is Beyond the Draft. By the end of this video, you will understand why the most practical idea in architecture was treated like a joke, and why it's more relevant today than ever before. Buckminster Fuller was born in 1895 in Milton, Massachusetts. He was expelled from Harvard twice. His first daughter died of illness. His business failed. In 1927, at age 32, he stood on the shore of Lake Michigan and considered ending his life. Instead, he made a decision. He would dedicate his life to answering one question: what can one man do to change the world? Over the next 30 years, he invented a 3-wheeled car, a prefabricated house, a new kind of map, and then, in the late 1940s, something that would change everything. The Geodesic Dome, a sphere made of triangles, the strongest, lightest, most efficient structure ever invented by a human being. Fuller explained it simply. Take a sheet of paper, no strength. Curve it into a cylinder, it becomes a column. Curve it into a sphere, it becomes almost indestructible, like an eggshell. The bigger you make it, the stronger it gets, and the more efficient. Most structures get weaker as they grow. The geodesic dome gets stronger. And then Fuller asked himself the question that nobody else was asking. New York City in 1960. Every winter, paralyzed by snow. Every summer, choking on smog. Snow removal cost the city a fortune. Heating and cooling, billions. Air pollution is getting worse every year. Fuller and his partner, architect Shoji Sadao, began drawing. The dome would cover midtown Manhattan, from the East River to the Hudson River, from 21st Street to 64th Street. 3 kilometers wide, half a mile high at its peak, 2.5 times the height of the Empire State Building. The structure would be a geodesic sphere. Thousands of interconnected triangular glass panels, shatterproof, one-way transparent. You could see out, but not in from the air. Electrical wires threaded through the glass would melt any snow on contact. Rain would simply run off the curved surface. One critic described it as like a vast but delicate soap bubble hovering over the city. Fuller didn't disagree. But while newspapers laughed, Fuller was running the numbers, and the numbers were devastating. Imagine Manhattan in January. No snow, no ice, no freezing wind, 65 degrees, sunny. You walk outside your apartment, no coat, no boots. The air is clean. The sky above, a delicate glass lattice filtering the sunlight. Your apartment doesn't have a heater. It doesn't need one. The dome maintains a constant temperature. Your energy bill, a fraction of what it used to be. New buildings inside the dome could be built lighter, cheaper. No need for weatherproofing, insulation, or heavy foundations. Architecture, freed from the weather. Air quality inside, controlled. pollutants filtered out, allergens removed. For the first time in a century, New Yorkers could breathe clean air. In summer, the dome filters direct sunlight. No more heat waves, no more humidity. The dome doesn't just block winter, it manages summer too. And then there's the money. This is where Fuller's argument becomes impossible to ignore. Fuller calculated the total surface area of every building under the dome. Then he calculated the surface area of the dome itself. The result shocked even him. The buildings had 80 times more surface area losing heat than the dome covering them. One dome, replacing 80 times the amount of weatherproofing. Fuller told an interviewer, "If you just had the covering out there, you'd reduce heat losses in New York 80 times. We would reduce energy input to about 20% of what you'd have to put in today." And then there's snow removal. New York City spends hundreds of millions every year clearing snow. Salt, plows, overtime pay, lost productivity. Fuller said, the savings from eliminating snow removal alone would pay for the construction of the entire dome in just 10 years. Fuller wasn't dreaming. He had done this math more carefully than anyone. He knew the bigger the dome, the better the economics. He had one famous line about it. "I began to study how big a dome I could build. And I found the bigger they got, the more favorable they were." So why wasn't it built? The math worked. The engineering was sound. The savings were real. What went wrong? The answer is painfully simple. Nobody took it seriously. Not because the idea was wrong, but because the idea was too big. Real estate developers didn't understand it. Politicians couldn't explain it to voters. Engineers had never been asked to build anything like it. Ordinary New Yorkers had a simpler objection. They didn't want to live in a fishbowl. The psychological barrier was as real as any engineering challenge. The proposal was filed away. No formal rejection, no official study, no government funding. It simply disappeared. Fuller, the world's most successful failure, was used to this. He once said, "You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete." But Fuller didn't give up. In 1967, 7 years after the Manhattan proposal, he got his chance to prove the dome worked, not over a city, but as the United States Pavilion at Expo 67 in Montreal. He and Sadao designed a 200-foot-tall geodesic dome, the largest of its kind ever built. It was spectacular. That dome still stands today, nearly 60 years later. It is now a museum dedicated to the environment. Fuller's Dome, still standing, still proving his point. In 2001, the Eden Project opened in Cornwall, England. Massive geodesic biomes housing entire ecosystems. They were built as a direct tribute to Fuller's work. Dubai announced the Mall of the World, an 8 million square foot temperature-controlled city enclosed in glass. Fuller's idea, reborn in the desert 60 years later. Every winter, New York freezes. Every summer, it bakes. Every year, climate change makes it worse. And every year, Fuller's idea becomes more relevant. Rising sea levels, extreme heat, superstorms. The problems Fuller wanted to solve in 1960 are the same problems killing cities today. Fuller died in 1983. he was 87. He never saw his Manhattan Dome built, but he didn't seem surprised.
He once said, "I'm not trying to imitate nature. I'm trying to find the principles she uses."
The geodesic dome was one of those principles. Nature builds in spheres. Humans build in boxes. Fuller wanted to change that. 65 years of no blizzards, no heat waves, clean air, billions saved on energy, the most livable city in the world, inside a soap bubble, designed by a man Harvard expelled twice. 65 years of no blizzards, no heat waves, clean air, billions saved on energy, the most livable city in the world, inside a soap bubble, designed by a man Harvard expelled twice. The dome was never built. But maybe, like the mile-high tower, like the underground train, it didn't need to be. Some ideas change the world just by existing, just by proving it's possible. Fuller believed that humanity's biggest problem wasn't technology. It was imagination. We can build anything. We just have to imagine it first. Next week on Beyond the Draft, a tunnel under the Atlantic Ocean, New York to London, under the water in less than 1 hour. Engineers have proposed it for over 100 years. The technology exists today. The cost? $3 trillion. And one country almost started building it. Subscribe so you don't miss the story. This was Beyond the Draft, the greatest things ever imagined, never realized.